We're going to use the same rules, but this time we just have to follow what we do with fractions. Okay? So for adding, we need to follow the rules for adding fractions and multiplying and so on. Okay, so we have these two problems. This is a situation where we add exponents because our operation is actually multiplication, but we add the exponents. So 1 plus 5 is 6, and it's still over 2. 6 over 2 would be a 3, so the answer to that is x to the third. Here, we want to combine like terms and just add the exponents. So we have 3/5, 2/5, which gives us x to the 5/5. Then we have 6/7, 2/7, which is y to the 8/7. Now the only thing we need to do now is to simplify any exponents. 5 over 5 would be 1, and an exponent of 1 is redundant, so we're just going to say x, y to the 8/7. Okay. Now, the next rule we're going to do, 1/2, no, let's not do that. Let's do 5/2. Okay, so this is where we do subtraction. So since we're doing division, we subtract exponents. So 5/2 minus 1/2 is 4/2, which is really just 2. So x squared would be the answer to that one. Okay, 3 minus 1 is going to be 2, so we have 2/2. 5 minus 2 is going to be 3. And both of those we can reduce. So 2 over 2 is 1. 1 is redundant, so we just write x. And then 3 over 6 is 1/2. Okay. Then we're going to say x to the 1/2 to the 3/5. And we're going to say x to the 5/2, y to the 1/3, and let's do 2 over 7. So this is a situation where we multiply. So 3 times 1 is 3. 5 times 2 is 10. 3/10 is simplified, so we're done. This one we're going to distribute. So we say 2 times 5, which is 10. 2 times 7, which is 14. That's not simplified, but we'll come back to it. 2 times 1 is 2, and then 7 times 3 is 21. So our y is finished, but we can divide both those by 2. So x to the 5/7, and then y to the 2/21. Okay. We don't really need to cover the raising to the 0 power rule, because that would be exactly the same. So the last thing we're going to do is negative exponents. So something like 1 over x to the 1/2, negative 1/2, y to the negative 5/3. Both of them are negative, so they need to come up top. And there's nothing left on the bottom. So that would be the final answer on that. Alright, now we are going to combine everything into a few problems. So 5 over 25, x to the negative 2, x to the 5, y to the 3, y to the, let's do a fraction here, negative 1/2, and then z to the negative 6/7, and z to the 1/7. Okay. So the first thing is, don't get so set on using these rules that you forget that you only use them when they're exponents. This first part right here, we just treat like a regular fraction. So if we had 5 divided by 25, we could change that to 1/5. Now I'm not going to write the 1 yet. I'm only going to write a 1 on top if there's nothing else on top. So I'll use it as a placeholder, but I don't have to write it. Now right here, x to the negative 2, I'm going to think of this like negative 2 minus 5, which is negative 7. And so I get x to the negative 7. Right here, 3 minus negative 1/2. So 3/2 minus a negative 1/2. So we have a double negative right here, so it's really a positive. So if it helps, change that to a plus sign. Now we have 3 plus 1, which is 4, halves, which is 2, so we get y squared. Okay, this one, negative 6/7 minus 1/7. So that's negative 7/7, which is negative 1. So we have z to the negative 1. Alright, we have 2 negative exponents, so both those need to move down to the bottom to become positive. So we still have our y squared on top, didn't move. We still have our 5 on bottom. But now we have an x to the 7, and we have a z to the 1, but since 1 is redundant, I'm not going to write it. Yeah, I think that is all we need to cover right now. So if you need additional help, please come to Math Lab. And for now, calculator.